Hi, I'm Paul. We are doing Leetcode must-know interview questions. Today's challenge is house robber. So imagine that you are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. So given an integer array, nums, representing the amount of money in each house, return the maximum amount of money you can rob tonight without alerting the police. Okay. This is a dynamic programming problem. Let me show you how this might work. I mean, you can do this. There's two primary ways of doing dynamic programming. One is top down, which is a recursive method where you memoize or keep track of the result of intermediate subproblems, so you don't have to keep doing the same subproblems over and over. Another way of doing dynamic programming is bottom up, in which case you tabulate the subproblems as you solve them. Now, so which way do you want to go? Well, if you have to solve all of the subproblems at least once, then bottom up is a good approach. If you because you'll save the overhead of the recursion calls. If it's possible that you don't have to compute all the subproblems, then you might consider a top-down approach. In this case, we have to calculate everything, and so we can take a bottom-up approach and tabulate the. Let me get a pen here, get the right color. Okay. So I'll show you how this is going to work. And we'll use we'll use example 2 here. All right? And we'll create a table. This will be a DP table. All right. DP. Really, the length of the DP table would be the length of the array, input array, plus 1. So that's 5. We need 6. So let's cut it in half, like right about here, 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 here. How many do I have now? 1, 2, 3, 4, 5, 6. Okay, that's fine. Index 0, 1, 2, 3, 4, 5. All right. Now we can start out by initializing a couple of cells in this array. Each of these cells is going to represent the maximum amount that we can get by robbing this number of houses, or that's not quite the right way to say it. It's going to represent the maximum amount that we can rob from this number of houses. So if there aren't any houses, then we're going to get nothing. If there's one house, That would be right here, 2. So if we're only going to rob one house, then we're going to get 2. Now, what if we want to rob 2 houses? All right, there's a couple of options here. We can either rob the next house, which is a 7. That's the second house. We can rob that. We can get 7 and add to that the maximum that we were able to get from 2 houses previously, because we can't rob 2 houses in a row. So what we can get is we can get 7 plus 0. Is that better than not robbing this house and just taking what we had from house number 1? It is better. It's 7 versus 2. So we'll go ahead and take the 7. Now we're on the third house. Third house is 9. Now the question is, are we better off robbing the 9 plus 2, or are we better off taking the 7? And actually 9 plus 2 is better. So we'll take that. We get to the fourth house, which is a 3. Are we better off robbing the 3 plus 7, which is 10, or are we better off not robbing this house and just taking what we could get from house number 3? And we are better not robbing this house and just moving what we could get from 3. All right, the last one is 1, and the question is, are we better off robbing the 1 plus the 11, or are we better off just taking the 11? And we're better off with 1 plus 11, which is 12. Okay, and that is the answer that we're looking for. All right, so let's make an observation here to simplify this, and that is that this is similar in a way to the climbing stairs problem, where we had, well, essentially we had a Fibonacci sequence to solve the climbing stairs. And so the solution to each subproblem, like how many ways can I climb this many steps, it really only required the solution to, it really only required the solution to the previous 2 problems. And this is really the same situation. So to figure out what's the most we can get from robbing some selection of these 5 houses, by the time we get up here, to 5, we don't care about these problems back here anymore. These are of no interest. The only thing we need to know to be able to solve this is at every point we need to know the numbers for the last 2 houses. So we don't have to keep track of the entire array. We can just keep track of the last 2 numbers. It makes it, I don't know. I mean, this is a perfectly good solution if you were to solve it this way. But we can simplify it a little bit by just keeping track of 2 numbers rather than doing the array. All right, so let's take a look at an implementation. So first of all, as a convenience, so that we don't have to keep referring to nums.length, let's just say int n equals nums.length. All right. Now, instead of doing the dp array and initializing that, let's just do this. If, well, actually n can't equal 0. We can, wait. No, that's fine. referring to the constraints here, nums has at least one. So n is never going to equal 0. All right, so we don't have to do n equals 0. But if n equals 1, then we'll just return nums at index 0. We robbed the first house. There's only one house. We're done. Short night for robbery. All right. Now, we got to keep track of values. So int, let's say previous, equals, this is once we get to house number 2. Right? So the previous house, because we've got a 0 indexed array, is nums 0. Okay. And what we can say, like the second previous, well, to start with, it's going to be 0. And this is similar to, the DP array. If there are no houses, then we get nothing. And we need that to make it work. So let's say int. What can we call the result here? We could call it loot. All right. Initially, our loot is 0. So let's go for int I equals 1. Now that's actually the second house, but if there's only one house, we've already taken care of it up here. All right, so for int I equals 1, I less than n, I plus plus, loot equals the maximum of the current house, which would be nums I plus second prev, so we can keep what we got 2 houses before, or previous, which is what we got from the house before. Whichever is more. Do we get more by robbing this house and taking what we had from 2 houses ago, or do we get more from skipping this house and just taking what we got from the previous house? Okay. Now we've got to switch the numbers. So we'll say, did I get that? Okay. So we'll say second previous equals previous, and previous equals loot. So again, each so previous will represent the most that we can get from robbing some collection of houses up to the current point. Second previous is, one house before that. Okay. I think that's it, actually. So we just keep track of those 2 variables, and so for each house, we calculate, does it make more sense to rob this house, or does it make more sense to skip this house and rob the previous house? Once we get to the last house, we're going to have the maximum amount that we could possibly have in the loot variable. try and run this. Okay, accepted. This is rated medium, but to me it's not really any harder than the counting steps. It's almost the same thing. Let's go ahead and submit. All right, good. So that's it for house robbing. You know, at this point you can decide whether or not you would like to continue with the programming, or you know, maybe go into the house robbing business. I hope you enjoyed the video, and feel free to like, comment, subscribe, and see you next time.